Okay, this is the second video of our problem set 6 here, and we just finished problem number 1, and now we're going to look at problem number 2. So let's see what we're going to do here for problem number 2.
Problem 2. A computer operations department had a business objective of reducing the amount of time to fully update an email user's messages in a special secured email system. An experiment was conducted in which 24 users were selected and 3 different messaging systems were used. 8 users were assigned to each system, and the update times were measured. The results are stored in file ams10.2.xlsx. Analyze the data and write a short report that includes.
Okay, let's look at the data. This is what it looks like, AMS10-2, and we see these are 3 systems. And these are download times. There are, looks like 8 different download times for 3 different users on these 3 systems. And so let's write some hypotheses here. The null hypothesis is that there is no difference in download times between the 3 systems. And so the alternative H1 would be there is a difference in download times between at least 2 of the systems. And so let's see where we are. So let's look at what we need to do here.
Question A. State the null hypotheses and alternative hypotheses.
Okay, we've done that. Next, question B is?
Question B. Show the output from PHstat that check assumptions.
Okay, we're going to check the assumptions here. So let's do that. Let's do add-ins, PHstat. Descriptive statistics. Descriptive summary. This thing pops up. And the data cell range is this range here. And it's multiple groups, unstacked. And I'm going to put a title here of email messaging system downloads. That's a plan. Downloads. Okay. And we get a new worksheet here which compares these 3. Let's look at them. We've got variance, our skewness and kurtosis. These 3, this looks like it's normal. This looks like it doesn't look normal. The skewness looks not so bad, looks symmetrical. Kurtosis, it looks peaked. So there's a clustering more in the middle. We notice the variance is lower. I don't know what that means. But then the skewness and kurtosis for system 3 are both between -1 and 1, so we would assume that data is normal. When we look at the standard deviations here, we look if we use the 2 times rule, we see that if one standard deviation is more than twice as variable as the other, there may be a problem. Doesn't look like that's a problem here. And so that looks good. So what's next?
Question C. Show the output from Excel that gives you the p-value for the ANOVA single factor analysis.
Okay, let's do the single factor ANOVA from Excel. I'm just going to do that just because it asks us to. We can go back to data. We can go to data analysis, single factor ANOVA. By the way, there's descriptive statistics here if you want to use those. But single factor ANOVA, okay. And this thing pops up, and we're going to look at these 3 columns here, labels in first row, alpha 0.05. We're going to do an output range. Let's put the mouse here to make sure, and I'm going to click right here. and click OK. And this is our analysis of variance. We're looking at a P of if it's less than 0.05, and this is in fact less than 0.05. So it looks like we're going to reject the null. There is a difference. Looks like this is the one that wins. There is a difference. The other way of looking at this is when we compute the F statistic, it's 5.1, and that is greater than the F critical of 3.4. If we want to actually look up what this 3.4 is, we've got our degrees of freedom of 2 and 21, and our F statistic here, which would be 2 and 21, is 3.47. And that's what we've got here. So we would reject. Now, but this doesn't tell us which one to choose. This doesn't tell us the differences between the two. We see here that on these averages, the 41, 36, and 35 is that we know it's obvious to us that there's going to be a difference between this one and this one because we rejected. But is there a difference between this one and this one? And if there is, then we definitely want to choose this one. Otherwise, probably either one of these would be okay. So to do that, we need to do Tukey-Kramer. And to do Tukey-Kramer, we need to do pH-stat. So let's click on add-ins up here. pH-stat, multiple sample tests, one-way ANOVA, and this thing pops up. Level of significance of 0.05. The range is these 3 columns. Title is going to be email systems downloads. And we do want Tukey-Kramer, so click OK. And it tells us we need to look up this Q statistic, and we'll do that. Click OK. Let's look up the Q statistic while we're at it. It tells us right here we've got 3 and 21, same as before. Let's look up the Q statistic, which is on page 530. And 321 is about 3.57. 3.57 or so. 3.57 or so, or 6 or something. So we do. So then that fills this in here, and we see that look, between group 1 and group 2, they're different. 1 and 2, they're different. Yeah, I believe that. Between group 1 and 3, that's 1 and 3. Yeah, I believe that. 2 and 3, however, the means are not different. So we did not see any significant difference between system 2 and 3. And from that, we would conclude that the difference we actually do see is just due to random error. So, what is the...
Question D. If the p-value is less than 0.05, include the pH-stat Tukey-Kramer output.
We did that. We just did that. And let's see.
Question E. From your outputs, write a concluding statement on how confident you are whether there is a significant difference in download means between the 3 systems. If there is a significant difference, then indicate exactly which systems differ significantly from which others.
Okay, very good. So you write this, but basically we know that we're confident that there's a significant difference. In fact, if we go back and look at our data here and go back to the analysis of variance, we are equals 1 minus the p-value we are 98% sure that there is a significant difference. Okay, that's how sure we are. That's how confident we are. And there's a difference, and if there is a difference, there is. Exactly which ones. And to find exactly which ones, we go to Tukey-Kramer, and we see there's a significant difference between the first two groups. There's a significant difference between the first group and the third group, but the second and the third group, there's not. The second and the third group, there is not. We could not show that there was any difference. So that's the answer to problem 2. And I'll conclude video number 2 for this, and come back and we'll do chapter 11, the problem 3. Thanks for watching.